Okay, so where were we? So now we know that we have this error in our subtraction, and that maps to this here. So what do we want to do? This is going to not be exactly in a functional calculator, like you wouldn't want your calculator to actually do this, but we're going to change our subtract method. We're going to call it difference, and we're going to change it to do an if statement. So to do an if statement, what we're going to do is type this capital IF and then instantiate this class. So in our if statement, what we're going to do is we're going to check is A bigger than B. If A is bigger than B, then what we're going to do is do B dot get minus B dot get, else we're going to do B dot get minus A dot get. So what we're doing here is we're saying we want our output to be this conditional thing where if A is bigger than B, then do A minus B. But if it's not, we're going to do B minus A. So breaking down what this if expression does, if we take a look here, our first argument is going to be our condition. Our second argument is going to be the then branch. So what to do if that condition is true. And then our third argument is going to be our else branch. So what to do if that condition is not true. So now if we go ahead and run our deploy again, because we need to change this difference. And now we can see we passed in 4 and 6. 6 is bigger than 4. So it did a 6 minus 4. And so now this is one way to write if expressions. What we can also do is we could have an if and then call dot then. I'm going to do output dot set b dot get minus b dot get, and then do a dot else b dot get minus get. So now what we've done here is the exact same code, except we've just used a different syntax. And go ahead and save this. Sure, it'll reformat for us. Then we can go ahead and run, and it'll work the exact same, returning 2. Now, the nice thing about this syntax is that it will allow us to also add else if. So we can add a else if. Let's do for a dot get equals b dot get, and then we're just going to return output dot set 0. Obviously, we don't need to do this, right? Our earlier methods would do it. Actually, let's change this so it's a little more obvious what it's doing. We'll change it so at the 1337, our elite return value. And so if we set both of these values to 4, we go ahead and call it, if our two values are the same, return 1337. And then just to show that other order also works, you can now see that it works like that. So that is our if condition. Common question is, why do we have to use this if class? Why can't we just use our if condition? I'm going to show you what that would look like. So let's structure this like a traditional Python if else and take a look at what happened. Okay, so let's go ahead and run this. So that works. So when A is bigger than B, it works as we'd expect. Let's go ahead and change this. And what the heck? We'll see that we got a result negative. And the reason that's happening is because this if expression, it's happening during compile time. So these values are always going to return an expression. So a.get returns greater than b.get. This whole thing returns an expression, and that's a truthy value. So this if expression will always evaluate to true during compilation. So when we actually compile our smart contract, this code here is never actually compiled to be on chain. It's only this code because this is an expression in Python, which is a truthy value. And that's why, again, anytime we want something to happen on chain, we have to represent it using a PyTeal expression. In this case, we're using our if, then, else if, and else expressions. So now we have our basic calculator. We have an addition and a subtraction. If we really wanted to, we could go ahead and make things like multiply, divide, maybe exponent, stuff like that. But it's mostly all pretty straightforward and the same. You just write a function and then do a whatever operation is associated with that function. So instead, let's change what we're doing here. And we're going to be adding some global state to our logic. So what this basically means is we're going to be saying that we want to save some value in our contracts each time we call one of our methods. So to do this, all we need to do is go up top to our before we create our application, and we're going to basically tell Beaker what our application state is going to look like. So to do that, we do class application state, and then we are going to say, we're just going to save a counter. And what this counter is going to be, this is going to be a global state value. And we are going to specify our stack type to be a kill type, but uint64. And so what we're basically doing here is we're saying we're going to have some application state and the first key value pair. So every state or every instance of state that we have in our application is going to be a key value pair. In our case, our key is going to be counter, and our value is going to be some unsigned 64-bit integer. So what we're basically saying is in our global state, which means in kind of the contract itself on the blockchain, we're going to be saving a value that's uint64, and that value is going to be referenced through a counter key. And now in order to our application, we're going to go ahead and say state equals application state. Now what we've done is we've told Beaker that in our application, this is the kind of state that we want to access. And we could specify more key value pairs, but here we're simply going to start off with just a counter. Now, one other thing we want to do is set a default value. So here, keep forgetting I have auto formatting on. So we're going to say our default, and this is going to be an int 0. So we want the default value for our counter key in global state to be 0. And the one last thing we have to do is actually initialize that default. So we're going to go ahead and create a create method. I'm going to call add_app.create. Then I'm going to set air equal to true, just so we don't have to specify a method when we want to create our application. And then in our logic here, I'm going to return app.initialize global state. Invalid syntax. Oh, so what? F create. There we go. So we have our create decorator, set bear equals to true, so it's easier to call, and then initialize our global state.